Okay, so a linear function up at the top. A linear function is just a function with a constant rate of change. Function with a constant rate of change. Okay, and that rate of change is change in y over change in x, which is also known as what? Oh, yes, okay. Right, yes, delta y over delta x. Well, what's our word for that? Slope. There we go. Change in y over the change in x, or delta y over delta x. They don't usually use delta in algebra 2. Sometimes in calculus, but. And of course, we have our linear equation, f of x equals mx plus b, or y equals mx plus b. Either one is sufficient. And of course, m is your change in y over change in x. So in order for something to be a linear function, that change in y has to be constant, and the change in x has to be constant. So if they give you a table of values like this, you're just looking at how do I get from each x, and is it the same? So how do I get from 0 to 2? Plus 2. How do I get from 2 to 4? Plus 2. And 4 to 6? Plus 2. So the x's is constant. The change in x is constant. Okay, we also have to check the y's. How do I get from negative 1 to 2? Plus 3. 2 to 5? Plus 3. 5 to 8? Plus 3. Is it a linear function? Yes, it is. Because the changes are constant on the x's and the y's. Okay, on B, how do I get from negative 1 to 2? Plus 3, 2 to 5, and 5 to 8. You guys are so awesome. On the y's, how do I get from 0 to 1? Plus 1, 1 to 3, plus 2. Is it linear? No. As soon as you see that it's not constant, then it's not linear. Okay, so slope. We talked a little bit up there about that. It's just your constant rate of change again. But it's specifically for a linear function. So it's nothing else besides linear function. So the reason we review graphing linear equations, especially talking about slope, is because in calculus you will see this a lot. So pre-cal you'll see it a little bit. You still have to know the background, but then in calculus they kind of take that basis and they build on it a lot. So you need to really make sure you know this stuff. Okay, so we already know, hopefully, slope is rise over run. That's usually the first thing you learn about slope. So of course, rise meaning up and down, run meaning left and right. If I give you a horizontal line like this, what is the slope of that line? I think I hear 0. Slope is 0. Okay, a horizontal line, it would be y equals something and a slope of 0. What if I give you a vertical line? What's the slope? Undefined. Good. And that would be x equals something. If you want to put that, you can. Y equals x equals. So first thing, they're going to give you a slope and a point, and you're just going to graph it. So this isn't too terrible. So on number 1, what would you do first? What would you graph first? Yeah, graph this point first. 1, 1. So over 1, up 1. And then we go to our slope. So what do I do for the slope? Up 2, right 3. Or rise 2, up, whatever you want to say. Up 2 over 3. And then from there I can also go down to left 3. Okay, make sure that your line has arrows on both ends because the domain and range of a linear function is all real numbers. So make sure you show that when you graph it. Okay, a positive slope is an increasing function. So on number 2, we have a negative slope. So we start at negative 2, 3. My slope is negative 1/3. So if I go down first, then do I go to the right 3 or left 3? Right. If I go down first, then I have to go to the right. So I look at it as negative 1/3. I went down 1, so I'm going to go right 3. So make sure that your function is decreasing from left to right. And that's, of course, the simplest thing you can do graphing a line, besides just giving points. Any questions on 1 or 2? Okay, we're going to skip number 3 because it's the same thing. Bless you. Just passing through a point. What's the slope there? 3 over what? 1. So you go up 3 over 1, but we won't do that one. Same as the others. Okay, so let's talk about intercepts. Does anyone know what x-intercept is? Perfect. Where it crosses the x-axis. So I'm going to say a point where the graph touches the x-axis. Point where the graph touches the x-axis. So when you're writing these, make sure that you always write them as coordinate points. Don't just write x equals or y equals because they are points on the graph. So x-intercept's always written as the number, comma, 0. So x, comma, 0, whatever that number is. The key here is that the y value is 0. And then, of course, your y-intercept is opposite of that, a point where the graph touches the y-axis. And that's written as 0, comma, your y value. So here the x value is 0. So we're going to find the x and y intercepts of each of those examples below. Does anyone still writing? Yes. Okay, so on A, I usually write x-intercept and y-intercept so I can find both. So if I'm finding the x-intercept, bless you, I'm going to plug 0 into the y. So I have 2x minus 3 times 0 equals 12. So if you're finding x, plug 0 in for y. If you're finding y, plug 0 in for x. And then just solve. And of course, what's nice about this is gone. So I have 2x equals 12. So x equals 6. Remember, don't leave it like that. So we're going to write that as a coordinate point, 6, comma, 0. And then the y-intercept, the 2 times the 0 goes away. So negative 3y equals 12. So y equals what? Negative 4. And that coordinate point is 0, negative 4. So you're finding at x and y intercepts, you have 2 coordinate points, and then you can graph those. So at 6 on the x-axis, and negative 4 on the y-axis. So the main thing with intercepts I see is people just forget where to begin. So think of that word intercept and what you know about intercepts. You know that it's on the x-axis and the y-axis, and you have the zeros to plug in. That's how I remember. Usually once you remember that, it's fine. Okay, so B, x-intercept, y-intercept. So same thing. If I want to find the x-intercept, I'm going to put 0 into the y. And if I want to find the y-intercept, I put 0 into the x. These are not very pretty numbers. So on the x-intercept, we have 6x equals negative 16. What does x equal? We have negative 16 divided by 6, and we want to reduce it. Don't leave it like that. So negative 8 over 3. And you don't need to write a decimal, just leave it exactly like that in fraction form. Is negative 8/3 in between negative 1 and negative 2, or negative 2 and negative 3? Good, negative 2 and negative 3. So make sure you graph it in the proper place. 3 goes into 8 2 times, and there's a little bit left over, so it should be further than the negative 2. And I graphed that on the wrong, oh no I didn't. Okay, the y-intercept. So on this side, 6 times 0 is 0. So 0 equals 14y minus 16. What did you do to solve for y here? Yeah, put 16 on the other side. Again, another ugly fraction, 8 over 7. So where is that on the y-axis? In between what? 1 and 2, right. 7 goes into 8 one time, so just right there. And then make sure you put those arrows on that line. Okay, the last one. So you have some fractions in there. To make it easier on ourselves, we can get rid of these denominators. How could I do that? Any ideas on how I could get rid of the 4s? Elizabeth?
Multiply both fractions by 4 and the negative 2.
Perfect. So the entire thing I'm going to multiply by the common denominator, which is a 4. And I'm out of space here, so I'll put it right there. Okay, it gets multiplied to the 3/4, the negative 2, and the 9/4. So everything gets it. Okay, so when I multiply it with the 3/4, the 4's cancel. So I get 3x minus 2 times 4, so 8y, equals, and then these 4's cancel, so it just equals 9. Okay, it just makes it a little bit nicer to get those x and y intercepts for you. So you don't have to worry about those fractions. You can keep the fractions, you don't have to do that. I don't have a lot of space left. So x-intercept would be 3x minus 8 times 0 equals 9. So that's gone. 3, 0. And the y-intercept, 3 times 0. Negative 9 over 8. Any questions on x and y intercepts? Hopefully it's not horrible. Hopefully the whole lesson's not horrible. It's a review for you. Okay, on the next page. So if you want on A, you're going to put it in slope-intercept form. So slope-intercept form is what? Remember? Y equals, yeah, there we go. Y equals mx plus b. So basically, anytime you want to graph a line, we want it in this form. Okay, of course, we could also say f of x, but usually when it's written out in an equation like this, you're going to see y. Okay, so how would I get it in slope-intercept form? What would I do first? Minus 3x. So I'm going to subtract 3x from both sides. Y equals negative 3x plus 5. And make sure you put it in that order. Don't put 5 minus 3x. I mean, it's the same thing, but put it in slope-intercept form. Okay, so this is part of your answer, the equation. How would you graph that? Where would you start? Yeah, positive 5. So if you don't remember, this is the y-intercept. So this is where we start. So I'll say start here. Sounds like some of you remember though. So 1, 2, 3, 4, 5. And then this is your slope. So your slope's negative 3 over 1. So from this point, I'll go down 3, right 1. Bless you. So the main thing is getting the equation slope-intercept form, because if you can't do that, your graph will be wrong. So this is the part where I want you to focus on. Okay, on the second one, how would you get the y by itself? How would you get rid of the 3 over 2? Multiply by, here I think reciprocal, hopefully. So you can divide by it if you'd like. It's just going to be super messy over here. So I multiplied the whole side by 2/3. I can't emphasize that enough. And so the 2/3 gets distributed. So we have y equals, this is gone, that's why you do that. Y equals 2/3 x minus what? Minus 2, right. So I'll do it over here. 2/3 times negative 2. Oops, negative 3, sorry. That's 3 over 1. The 3's cancel, so you just get negative 2. And I'm not going to graph that. I think most of you are okay with graphing. I just want to make sure you know how to get y by itself. Okay, on C, how would you get y by itself on C? Plus, you can add y. Someone in my other class said that too, and that's totally fine. I always keep y on the left, and I just work from there. So if you want to add y and then subtract 6, you can. I go this route. It does not matter to me, whichever one is more comfortable for you. So I'm going to add the 2x over. If you want to do it the other way, that's fine. And we should get the same answer. So negative y equals 2x plus 6. And of course, this needs to be a positive y. So what do I have to do? Divide by negative 1. So it basically everything changes signs. Y equals negative 2x minus 6. So you should have gotten the same answer if you added the y and subtracted the 6. It would be the same thing. Okay, on D, x equals negative 4. How would you graph that? X equals negative 4. Is it a vertical line or is it horizontal? It's vertical, so it's on the x-axis because it says x equals. So at negative 4 on the x-axis, I'm just going to put a point and graph straight up and down. And what is the slope of that line? Undefined, right. Slope is undefined. So on a line like that, make sure you know the slope is undefined. If it's a horizontal line, what's the slope? 0. Good. Okay, that last one. Let's go ahead and see if we can get rid of those fractions. So if I want to eliminate the fractions, I want to get rid of the denominators. I need to multiply by the common denominator, which is what? 8, right? I have a 4 and an 8. I want to take the bigger one. So I'm going to multiply the entire thing by 8. So make sure here that you go all the way to the other side of the equal sign as well. So on the 3/8x, the 8 would cancel, and I would get just a 3x. How about here, when I have 8 times 5 over 4? 10 y. So if you don't know that, I'll put it right here so you can see. 8 times 5/4. You can multiply across. 40 divided by 4 is 10. The way that I do it is I say 4 goes into 8 twice, so I did 2 times 5 is 10. Either way. If you have trouble with those fractions, though, make sure that you come and see me so we can work on it. And then that equals 8 times 5 is 40. And we won't graph that one because it's too big. I don't know why it says don't graph. Okay. So then the last thing is inequalities. I think it's the last thing. Yes, the last thing is inequalities. So basically the same as graphing a line, you just have extra stuff added to it. So we have, we first want to make sure that our inequality is in slope-intercept form. And what is slope-intercept form again? Good. Y equals mx plus 8. So make sure y is by itself. So on number 1, that's already done for us. Y is by itself. Okay, so let's go ahead and graph number 1. Where do I start at on my coordinate plane? Positive 1. So positive 1 on the y-axis. And what's my slope? 2 over 1. So up 2 over 1. Up 2 over 1. Okay. So with inequalities, if you read that step number 2, it says graph the boundary line as dotted if it's less than or greater than, or solid if it's less than or equal to, or greater than or equal to. So because I have just a greater than, this is going to be a dashed line. So just don't connect it all the way. So that would be like your open circle and the number line. And then step 3, shade the solution set. So on an inequality, instead of, if I have a line, just like a regular line like this green one, that is my, your solution would be maybe wherever, probably like right here on your x-axis. When you have inequalities, you have this entire area that's your solution. So we have to figure out which side is it. Is it this side or is it this side? So some of you may just say, oh, I already know which side it is by looking at the symbol, but I want to make sure you know the surefire way to figure it out. And that is to pick a point. So you can pick any point that's not on the line. I usually pick 0, 0. Okay, so 0, 0 is not on my line, and then I just plug it in. 0 is greater than 2 times 0 plus 1. Is 0 greater than 1? True or false? False. So here's 0, 0. Because it's false, I'm going to go to the other side, and that's where I shade. So this whole thing is my solution. Any point in there would work. So I know some people are saying, well, can't I just see that it's greater than the line? That's fine, but sometimes if you get lines that are very, like really vertical or horizontal or something, this is just a surefire way to make sure you know which way is shaded. So you don't mess that up. Okay, number 2. What do we need to do first on number 2? Yeah, get y by itself. So let's subtract over 4x. Y is less than or equal to negative 4x plus 12. So divide by 3. Make sure you're dividing each piece by 3. So y is less than or equal to negative 4/3 x plus 4. So I'm going to look for this on your paper. Make sure you have that equation somewhere. For So we start where? Positive 4. And our slope is negative 4 over 3. So down 4, right 3. Is it dashed or solid? Solid because of the equal sign. So it gets a full line. And again, 0, 0 is not on the line, so I'm going to use 0, 0. So I'll put 0 is less than or equal to negative 4 thirds times 0 plus 4. This cancels. Is 0 less than or equal to 4? Yes, so here's 0, 0, so I shade the side that has the 0, 0. Okay, I want you to work number 4. Go to number 4. Work number 4. Okay, what's special about this one? Yes, you're dividing by a negative 8, so be careful here that inequality symbol flips. And I see some people forget it sometimes when we do this, just because we're graphing, so make sure that you flip that sign. Have a solid line because it has the equal sign under it. So when I plug in 0, 0, you do not have to do that. You really don't. If you can figure it out, some people I know just look at it and that's fine. I just think it's helpful to figure out which way that you're shading in case you get confused. So things that I look for on these problems, there's a lot to look at. I look for the equation, and then did you graph the line right? Did you do the the solid or dashed line correctly? And then did you shade it correctly? So there's lots to look at here. So it's very much a partial question on the test, but hopefully you get it all right. Okay, last two. I think there's a couple of these on your homework where you have the line is already shaded and you're going backwards. So we want to write the inequality for the graph. So the first thing I would start with what is the y-intercept and what is the slope. So the y-intercept is what? Good, positive 5 right here. So y-intercept is positive 5. And then, I don't know if you can see that here, there's another point at 3, 1. So that's how I got the slope. So down 1, 2, 3, 4. So negative 4 over 3. So with those two pieces of information, I'm basically putting it in y equals mx plus b form, except this will be an inequality symbol. So I have y, I'm going to leave that blank for a second, negative 4 thirds x plus 5. So if you have the slope and the y-intercept, we should be able to then write the equation. So you can plug in a point here. So what I do is I do the same thing I do on the others if you're unclear as to which way to put it. So I take 0, 0, and I'm going to put 0 in. So if I put 0 in, I still don't know the symbol here. The 0 plus 5. So that's gone. So I have 0 is what to 5. Now 0, 0 is not shaded, which means this needs to be an untrue statement. So that means it should go this way because 0 is not bigger than 5. So that can be confusing. The other thing you can do is instead of picking 0, 0, you can pick something in the shaded region. Any point that's in the shaded region and see if it's true. And that way you know which way to put your symbol. So this one should be y is greater than. Does it get an equal sign? No, because it's dashed. Okay, so this is my equation right here. Okay, last one, word problem. There's, I think, one word problem on your homework, or two maybe, I don't remember. A recreation center offers 30-minute and 60-minute art classes. The director has allotted up to, so this is key here, up to 20 hours a week for art classes. Now, first thing I would notice is you have minutes and hours. So let's change this 20 hours to minutes. So I would do 20 times 60, which is what? There we go, 1,200. Okay, so that way everything is in minutes. Okay, so make sure you look at your units here. So it says, write an inequality to represent the number of classes that can be offered per week. So you can pick whatever variables you want. I'm just going to use x and y. So I'm going to say x is the number of 30-minute classes, and y is the number of 60-minute classes. Okay, so I have I'm going to put my box there. That's my inequality sign. Here's my total minutes, 1,200. So then we have our 30-minute classes, so 30x. So your 30 minutes times the number of classes, plus your 60-minute times the number of classes. So it says up to 20 hours per week. So is it going to be a greater than symbol or a less than symbol? Less than? Oh, I hear less than or equal to. Okay, if you get confused, which sometimes it is confusing, you can pick a number. So like, let's say if it's 20 hours and I put in 19. 19 is less than 20 and 19 is getting closer up to 20. If I put 21, I can't go past 20 if it says up to 20. So if you put numbers to it, sometimes that can help with the verbiage here. Okay, so that's it. You're just writing the inequality. We're not going to graph it. The one on your homework, if you turn to the back page of your homework, omit part B. It says graph it, but they're crazy decimals. So the third page of your homework, you can take that out. That's just the graphing part on that last one. So on the homework, you're going to give me an equation like this, or an inequality. Then it says, can the recreation director schedule 25 of the 30-minute classes and 15 of the 60 during a given week? So what would you do with that information? Yeah, you just plug it in. So 30 times 25 plus 60 times 15 plus you. And we want to see, is that less than or equal to 1,200? So what is this? 750 plus 900. Is that less than or equal to 1,200? 750 plus 900? No. Explain your reasoning. So there's not enough minutes in the week, not enough time during the week. Whatever you would like to say there. That makes sense. So the biggest thing is getting the equation right, though, because if your equation's not right, then this second part won't be right. Okay, so your homework from last night, again, my answer key's up there if you want to look look at that. If you want to check your answers, I would recommend that.